this, you are in an interview and the interviewer asks, "Can you write a query to find the top 5 sales records?" You freeze for a moment, thinking, am I ready for this or not? Don't worry, SQL might sound complicated, but it's actually a super useful tool that lets you interact with databases. Have you ever wondered how all those apps and websites stores and organize their data? Well, that's where SQL comes in. SQL, which stands for Structured Query Language, is a universal language for talking to databases. It's super powerful and lets you do things like pull out specific information, add new data, update existing stuff, or even delete things you don't need. It's basically your magic key to manage huge amounts of information with ease. Exactly. And if you're aiming for a career in tech, whether it's a database administrator, data analyst, or software developer, SQL is a must-have skill. Databases are at the heart of almost every application. So knowing SQL can unlock some really exciting opportunities. Now here's the exciting part. This video is your secret weapon to master SQL interviews. We have packed it with 45 carefully chosen SQL interview questions that cover everything you need to ace those tough questions. So we'll be starting with the basics like how databases work and then diving into advanced query challenges, and by the end you'll be fully prepared to tackle any SQL question thrown at your way. So let's dive in and get you closer to your dream job. Before we commence, if you are interested to advance your career in data analytics, here's an opportunity for you. The postgraduate program in Data Analytics by Purdue University in collaboration with IBM is designed to equip you with the skills needed to succeed in the data analytics field. This 8-month program features live interactive sessions, real-life projects, and case studies that provide hands-on experience. So you can find the course link in the description box and in the pinned comment. So let's get started. So now let's start with a SQL interview question. We'll cover every question starting from basic level to advanced level. So now let's look at our first question, which is very basic. What is SQL? So we all know that SQL stands for Structured Query Language, and it is the language which is used to talk to databases. Think of it like giving instructions to a computer system that stores and organizes data. For example, if you want to find out all the customers who ordered a specific product, then SQL can help you do that with a simple command. You can also use SQL to add new data, like entering a new customer details into a database. If you want to update someone's phone number, SQL has got you covered. Or maybe you want to delete old records that are no longer needed, SQL can handle that too. Here's a quick example. If you want to find all the customers in New York, you could write something like select star from customers where city is equals to New York. So we are using this command to find all the customers in New York. Remember, if you want to find out all the specific data from the table, you have to use the star command. And if you want to add new customer, you can just simply write insert into customers, name, city, and then you can also insert value name, which is John, and you can just enter the specific location. So SQL works the same way across many popular databases like MySQL, PostgreSQL, or SQL Server, which is why it's such an important skill for anyone working with data. So now let's look at our second question, which is what are the different types of SQL commands? So SQL commands are like instructions you give it to a database to tell it what to do. There are different types of commands and each one has a specific purpose. So let me explain these in simple terms. Remember, if an interviewer asks you such questions, simply explain using the proper keywords and use proper definitions and easy language. That's it. So the DDL command we have, which stands for Data Definition Language. It basically defines the structure of the database. For example, if you want to create a table, or if you want to alter a table, or if you want to drop a table. Then we have DML, which stands for Data Manipulation Language. It deals with the actual data in the database. For example, insert, update, delete, all of these things. Then we have DCL, which is Data Control Language. It will manage permissions and access control. So if you want to manage permission or access control, then you have to use this particular type of SQL command, which is DCL, which is grant and revoke. Grant will provide access rights and revoke is used to remove the access rights. We also have TCL, which stands for Transaction Control Language. It will manage transactions in the databases. For example, Commit is used to save changes, rollback is used to undo changes, and save point is used to create intermediate points in a transaction. So for instance, in a schema with customers table and an order table, data definition language commands are used to define the table, whereas data manipulation commands, which is select, insert, and delete, it is used to update customer or order data. DCL is used to control access, and TCL, which is transaction control language, is used to manage transactions. That's it. It was very simple. Now let's look at your third question, which is what is a primary key in SQL? A primary key in SQL is like a unique ID for each record in a table. Think of it as a way to ensure that no two rows in a table have the same value. Remember that no two rows must have the same value. It is also a rule that the primary key column can't have empty or null value. So these are the basic criteria for a key to be a primary key. For example, in a table of customers, you have a column called customer ID as the primary key. Then each customer have a unique customer ID like 1, 2, 3 and so on. This makes it easy to identify and retrieve specific customers from database. Here's a simple example. Suppose we have created this table, create table customers, and we have given the customer ID as primary key. We have given name as varchar, the city name as well. So the primary key will ensure that each customer ID is unique, no duplicates are there, no customer ID is left blank, that is there should be no null values, and primary keys are also important when linking tables together. For example, if you have orders table, you can use the customer ID as a reference to connect each order to a specific customer. This helps maintain data integrity across the databases. Now the fourth question is, what is a foreign key? A foreign key in SQL is like a connection or link between two tables. It's just like a field in one table that refers to the primary key in another table. This creates a relationship between the tables and ensures that the data stays consistent. For example, let's suppose you have two tables, a customer table with a primary key called customer ID and a sales table with a field called customer ID, which is a foreign key linking back to the customer ID in the customers table. So here's how it will look like. We have created this table and you can see in this example that suppose we have customers and sales table. So we have used this customer ID in our customer table as well. So here customer ID is the foreign key and in the customer table, the customer ID which we had used is the primary key. So now let's move on to our fifth question, which is delete and truncate command. What is the difference between delete and truncate commands? So delete and truncate commands in SQL both remove the data from a table, but then they work in different ways. Let me break it down for you. The delete command. So what delete command will do is basically, this is used when you want to remove specific rows from a table based on a condition. For example, if you want to delete all the customers from a specific city, then you have to use this delete command. It will allow you to be selective, but it's slower because it logs each row deletion, which also makes it possible to roll back the changes if needed, if you're using transactions. Moving on to truncate command, truncate will remove all the rows from a table at once without allowing any condition. For example, if you just want to remove all the rows just in a one go, you have to use this truncate command. Just simply write this query as truncate table. Suppose the table name is customers. Is much faster because it doesn't log individual row deletions and it simply clears the entire table in one go. However, you can't roll back a truncate operation in most databases once it's done. So the key differences is delete is for specific rows, truncate is for clearing the entire table. Truncate is much more faster because it uses fewer system resources. Delete can be rolled back if used within a transaction. Truncate usually cannot. Delete logs each row deletion and truncate doesn't. So this was all for this truncate and delete command. So anytime if the interviewer asks you such questions, just simply explain this. Now let's move on to the sixth question, which is, what is a join in SQL and what are its types? So this is one of the most important questions you'll be getting to know in the interviews. You'll be asked such questions in the interviews. So basically, a join in SQL is used to combine a data from two or more tables based on related column, like a column key that links them together. It's just like connecting pieces of puzzles. Join help you see the bigger picture by merging related data. For example, if you have a customer table and a sales table, you can use the join to see which customer placed which order by linking them through a common column such as the customer ID. So you all know what a join in SQL, and let's discuss its type. So join types are basically, there are 4 types of join, which is inner join, left join, right join, and full outer join as well. So what inner join will do is it will combine rows from both tables where there is a match in the common column. Think of it as the overlapping section in the Venn diagram. Only rows that exist in both the tables are included. The left join, or we can call, or the left outer join, it will retrieve all the rows from the left table and the matching rows from the right table. Remember, the left join will retrieve all the rows from the left table and only the matching rows from the right table. If there is no match, the result includes null values for the right table's column. Think of it as including the entire left circle in the Venn diagram along with any matches in the right circle. Right join or the right outer join is similar to the left join, but it will retrieve all the rows from the right table and matching rows from the left table. If there is no match, null values are included for the left table column. Think of it as including the entire right circle in the Venn diagram along with any matches on the left circle. Then we have the full join. Full join will combine rows when there's a match in the either table. If no match is found, it includes null or the missing values from the either table. Think of it as combining both circles in the Venn diagram. Everything from both tables are included. Now let's move on to the 7th question, which is, what do you mean by a null value in SQL? It's very easy. Null value in SQL means that a column has no data. It's missing or unknown. It's not the same as an empty string or the number 0. Those represent actual value, while null represent no value at all. For example, if you have a table of customers and one of the row doesn't have a phone number, then the phone number column for that row would be null. See, we have listed this in the table here, you can see. If you do not have any data, just simply write null. So the next question is, define a unique key in SQL. So a unique key in SQL ensures that all values in a column or a combination of columns are unique. That is, no duplicates are allowed. It's like having a rule to make sure that no 2 rows in a table must have the same value in that column. For example, in a user table, the email column can have a unique key to ensure that no 2 users can register with the same email address. Remember the key points. Unlike a primary key, a table can have more than one unique key. Unique keys allow null values while primary keys do not. So these are very important to remember. So if you're asked a difference between a primary key and a unique key, just simply say that unlike primary key, a table can have more than one unique key, and unique key allows null values while primary key doesn't. So here is a table we have listed below, that is create table users, and we have given user ID as integer primary key, and then we have email varchar as a unique key. So here the email column is a unique key so that each email must be different. It should not be the same. Now let's look at our next question, which is, what is a database? A database is an organized way to store and manage data. Think of it like a digital filing cabinet where information is neatly arranged in tables with rows and columns. Each row represents a record and each column represents a specific detail about that record. For example, a database for a library must have a table for books. Then the rows could represent individual books and the columns could include the book title, author, and the publication year. The main purpose of a database is to make it easy to store, manage, and quickly retrieve data whenever you need it. Databases are used in everything from apps and websites to banking system and e-commerce platform. Now let's look at our question number 10, which is explain the differences between SQL and NoSQL databases. So here's a simple explanation. SQL databases are structured, which means they can store in tables with rows and columns, like a spreadsheet. They follow predefined schema, meaning the structure of a data is fixed and you need to define it before adding any data. These databases are great when you need consistent and reliable data, like for banking system or inventory management. Examples are MySQL, Oracle, MS SQL, PostgreSQL, etc. And SQL databases are also known as RDBMS, which is Relational Database Management System. Let's talk about NoSQL databases. So NoSQL databases are flexible and do not use table. Instead, they can handle unstructured or semi-structured data. So NoSQL database is dynamic, where data is primarily stored in JSON objects, key value pair, graph nodes, etc. They don't have a specific structure. Such databases are mostly not preferred for performing complex query operations, and the examples include MongoDB, CouchDB, Elasticsearch, etc. So now let's move on to question number 11, which is what is a table and a field in SQL? So a table is like a spreadsheet that stores data in an organized way using rows and columns. Each table contains records and the details. For example, a table named employees could store information about employees in a company, whereas a field is a column in a table and it represents a specific attribute or property of the data. For example, in the employees table, fields could be employee ID, name, and department. So here's a simple example of the table. You can see here the fields name, or we can say column, and we also have the records or the rows, we can see that. So in this table, the entire table is called employee. Each row or record stores information about one employee, and each column or field represents specific details like employee ID, name, and the department. Now let's move on to a question number 12, which is describe the select statement. Well, the select statement in SQL is used to retrieve data from a table or multiple tables. It's like asking databases, show me the specific information. Here's how it works. You can specify which columns you can see. For example, to retrieve all customer names from a customer table, you can select name from customers. If you want to retrieve all the data, just write this query, select star from customers. Remember, I told you before in the first question, we are using star if you want to retrieve all the data from the table. And if you want to just retrieve from a particular row or a column, just simply write, select name from customers, the field name. You can also apply filters. You can use the where clause to filter the results. For example, you can write select name from customers where the city name is New York. You can also sort the results. Use the order by to sort the data. For instance, to sort customers by the name, you can just write select name from customers and then order by name ASC. ASC means ascending order. So in short, the select statement lets you choose what data you want to see. Now let's talk about what is a constraint in SQL and name a few. So if you ask this question, just simply answer a constraint in SQL is a rule applied to a table that ensures the data stored is accurate and consistent. It also helps in maintaining data integrity by restricting what values can be added or modified in a table. Here are some common constraints: primary key, we have foreign key, then we also have unique key, check, not null, and default. So we have already discussed about primary key. It ensures that each row in a table has a unique identifier and the column can't contain null values. Foreign key links to a column in one table to a primary key in another table to maintain relationship. Unique key ensures all the values in a column are distinct, that is, there are no duplicates. The check ensures that data meets a specific condition before being inserted or updated. Not null ensures that a column cannot have null values. The constraints are essential for maintaining reliable and valid data in your database. Now let's talk about what is normalization in SQL. Normalization in SQL is a process which is used to organize data in a database to make it more efficient and reliable. The goal is to reduce redundancy, which is duplicate data, and ensure data consistency. This is done by splitting a large table into smaller related tables and then linking them using relationship like primary and foreign key. For example, imagine a single table that stores customer details and the orders. If the same customer places multiple orders, then their information like name and address would be repeated for each order. Now, using normalization, you would separate this into two tables. First, we would have customer table, which will store customer details like customer ID, name, and the address. And then we have order table, which will store order details like order ID, customer ID, and the order date. Now, by linking these tables using customer ID, you can also reduce duplication and ensure that any changes to customer details are updated in just one place. Now let's talk about question number 15, which is how do you use the where clause? It's very easy. So just answer the where clause within SQL queries serves the purpose of selectively filtering rows according to a specified condition, thereby enabling you to fetch exclusive those rows that align with the criteria you define. For example, select star from employees where department is equals to HR. Now let's move on to question number 17, which is difference between union and union all. So union is used to merge the contents of two structurally compatible tables into a single combined table. The difference between union and union all is that union will omit duplicate records, whereas union all will include duplicate records. Very easy. Union will omit duplicate records and union all will include duplicate records. The performance of union all will typically be better than union since union requires the server to do the additional work of removing any duplicates. So in cases where it is certain that there are not any duplicates or where having duplicates is not a problem, then we can use union all. It would be recommended for performance. So now let's move on to the question number 18. So here a table is given below and you will have to say what will be the result of a query. The query is select star from runners where ID not in, select winner ID from races. So the answer is, given the simple data provided, the result of this query will be an empty set. So the reason for this is as follows. If the set is being evaluated by the SQL not in condition contains any value that are null, then the outer query here will return an empty set, even if there are many runner IDs that match winner IDs in the races table. Question number 19 is what are indexes in SQL? Indexes in SQL are just like having a shortcut to quickly find data in a table. Instead of searching through every row one by one, an index creates a sorted structure based on one or more columns, making data retrieval much more easier. For example, you can think of an index in a book. If you're looking for a specific topic, you can go to the index at the back and find the page number instead of flipping through every page. Similarly, in database, an index helps the system quickly locate the rows you need. So, here's how it works. If you often search for customers by their name, creating an index will speed up those queries. You can just write create index IDX customer name on customer and then the customer name. The database uses the index to find the row, so you just have to run a query which is select star from customers where name is John, and then you can use the index to find the row with name is equals to John much faster. Let's move on to question number 20, which is explain group by in SQL. The group by clause in SQL group rows with the same values in a column, allowing you to apply functions like sum, count, or average to each group. For example, in a sales table to find total sales by region, you just simply have to write this query which is select region, some amount as total sales from sales group by region. So the group the sales by region and calculates the total for each. It's a quick way to summarize data by categories. So now let's talk about question number 21, which is what is an SQL alias? A SQL alias is a temporary name you can give it to a table or a column in a query to make it easy to read or work with. It's like giving a nickname to something for clarity. For example, if you have a column named first name, you can use an alias to rename it as first name in the query results. You just simply have to write this query as select first name as first name in capital letter, last name as last name from employee. Here the AS keyword assigns the alias and the output will show the columns as first name and last name. Aliases are also useful for tables. So for this, you can just write the code as select E first name from department table. So this shortens table name for easier referencing. Aliases are not permanent, they only exist while the query is running. Now let's talk about the question number 22, which is explain order by in SQL. So you can answer this question like the order by clause in SQL is used to sort the result set of a query based on one or more columns. You can specify each column sorting order, ascending or descending. For ascending, you have to use ASC, and for descending, you have to use DESC. Okay. So just have to simply write this query as select star from product order by price DESC. Now let's talk about question number 23, which is differences between where and having in SQL. The where clause is employed to restrict individual rows before they are grouped, such as when filtering rows prior to a group by operation. Conversely, the having clause is utilized to filter groups of rows after they have been grouped, like filtering groups based on aggregate values. The having clause, it cannot be used without the group clause, whereas the where clause specifies the criteria which individual records must meet the selected query. It can be used with the group by clause. Question number 24 is, what is view in SQL? One more important question. So, an SQL view is essentially a virtual table that will derive its data from the outcome of a select query. Views serve multiple purposes, including simplifying intricate queries, enhancing data security through an added layer, and enabling the presentation of targeted data subsets to users, all while keeping the underlying table structure hidden. Now let's move on to question number 25, which is, what is a stored procedure? So if you are asked this question, just simply say a SQL stored procedure comprises of pre-compiled SQL statements that can be executed together as a unified entity. These procedures are commonly used to encapsulate business logic, improve performance, and also ensure consistent data manipulation practices. That's it. Now let's move on to question number 26, which is one more important question, which is, what is triggers in SQL? A SQL trigger consists of a predefined sequence of actions that are executed automatically when a particular event occurs, such as when an insert or delete operation is performed on a table. Triggers are employed to ensure data consistency, conduct auditing, and streamline various tasks. So you can use insert trigger, update trigger, or delete trigger accordingly. Now let's talk about what are the aggregate functions, and if you know them, name a few. It's very easy to answer. Aggregate function in SQL perform calculations on a set of values and return a single result. At first, we have minimum, which will get the minimum value from the resultant set. Then we have the max function, which will give you the maximum value from the resultant set. The sum will give you the sum of values from the resultant set. Average will give you the simple average of the resultant set. And the count will count of numbers records from the resultant set. Now let's talk about question number 28, which is, how do you update a value in SQL? The update statement serves the purpose of altering pre-existing records within a table. It involves specifying the target from the update, the specific columns to be modified, and the desired new values to be applied. For example, if you want to update, you can use query like update employees, set salary is equals to 6,000 where the department is IT. Now we'll be moving on to some intermediate SQL interview question and answers. So one of the question is, what is a self-join and how would you use it? I would like to repeat again, these join types of question is very important. These are often asked in interviews. So talking about what is a self-join in SQL is a type of join where a table is joined with itself. It's useful for comparing rows with the same table or exploring hierarchical relationship, such as finding employees and the managers in an organization. So imagine if you have an employee table. So you have employee ID, name, and the manager ID. So if you want to find each employee and the manager, you can use a self-join. You can just simply write a query as select ename as employee, mname as manager, from employee, left join employees on manager. So I've already discussed with you before what is the meaning of left, right, and self-join. So here the table joined with itself using manager ID to link each employee to the manager. A self-join is helpful for comparing rows in the same table or working with hierarchical data. So now let's move on to question number 30, which is explain different types of joins with example. At first, we have inner join. The inner join will gather rows that have matching values in both the tables. Then we have the right join. It will gather all the rows from the right table and any matching rows from the left table. Left join will gather all the rows from the left table and any matching rows from the right table. And the full join will gather all rows where there is a match in either table, including unmatched rows from both the tables. Very easy. Now let's move on to question number 31, which is, what is subquery, and provide it using an example. So subquery basically refers to a query that is embedded within another query, serving the purpose of fetching information that will subsequently be employed as a condition or value within the encompassing outer query. So you can just use this query, which is select name from employees, where salary is greater than select average from salary from employees. Now the next question is, how do you optimize SQL queries? So basically, the answer to this question would be something like SQL query optimization involves improving the performance of SQL queries by reducing resource usage and execution time. Strategies include using appropriate indexes, optimizing query structure, and avoiding cost operations like fully table scans. Now let's talk about question number 33, which is, what are correlated subqueries? It's a type of subquery that makes reference to columns from the surrounding outer query. This subquery is executed repeatedly, once for each row being processed by the outer query, and its execution depends on the outcomes of the outer query. Now we'll be talking about what is a transaction in SQL, and it's very important. One of the most important questions asked every time in SQL interview questions. So basically, a transaction in SQL is a group of one or more SQL commands that are treated as a single unit. It ensures that all the operations in the group either succeed completely or fail entirely. This guarantees the integrity of the database. Imagine you're transferring money from your bank account to a friend's account. Then the bank first deducts the amount from your account and then it adds the same amount to your friend's account. These two steps together form a transaction. If one of these steps fails, example, the system crashes after deducting money from your account but before adding it to your friend's account, then the entire transaction is rolled back, meaning no money is transferred and the database returns to its original state. So you can also explain this question with the help of example that would be more, clear to the interviewer. Now let's talk about what are ACID properties in SQL. So basically, ACID stands for atomicity, consistency, isolation, and durability. And these are key properties that ensures database transactions are reliable and maintain data integrity. Atomicity, you can think of it as all or nothing. A transaction is a single unit of work. If any part of the transaction fails, then the entire transaction is rolled back and no changes are made to the database. For example, if you're transferring money between two accounts, either both the debit and credit operations happen or neither does. The second we're going to talk about is consistency. The database must always be in valid state. A transaction takes a database from one valid state to another, following all the rules and constraints. For example, if a transaction adds a record that violates a rule, like a duplicate primary key, then the transaction fails, keeping the database consistent. Isolation, transactions don't interfere with each other. Even if multiple transactions are running at the same time, each transaction works as if it's the only one happening. Example, if two people are updating the same record, then one transaction will wait until the other is complete. Talking about durability, once a transaction is committed, it's permanent. Even if there's a power outage or system failure, the data is saved and it won't be lost. After you complete an online purchase, the transaction is stored securely even if the server crashes immediately after. So this was for the ACID properties. And now we'll be moving on to our next question, which is, how do you implement error handling in SQL? Error handling in SQL is a process to manage and respond to errors that occur during query execution. Different database systems have specific ways to handle errors. In SQL Server, the try-catch block is commonly used. The try block contains the main operation, while the catch block handles errors if they occur. For instance, in a transaction, you can use rollback in a catch block to undo changes if something goes wrong. Similarly, in Oracle, the exception block within PL SQL is used to handle errors. If an error arises, the exception block executes, rolling back the transaction and then logging the error message. By implementing error handling, you ensure that operations fail gracefully without corrupting data, making the database operations more reliable and secure. Next question, which is, describe the data types in SQL. SQL supports various types of data types which define the kind of data a column can hold. These are broadly categorized into numeric, character, data type, and binary types. So we have numeric data types like integer, float, then we have character string like char, varchar. We also have Unicode character string like ncat, ntext. Then we have binary, which includes binary image, date and time, which includes date and date and time. Then we also have some miscellaneous data types, which is XML and JSON. So the next question is explain normalization and denormalization. Often this question is asked in this way also, or it could be asked something like explain the difference between normalization and denormalization. So to answer this, you have to just simply explain what normalization is, which I have already discussed before. Once again, I'm saying you normalization and denormalization are ways to organize data in a database. Normalization is all about breaking big tables into smaller ones to remove duplicate data and improve accuracy. For example, instead of repeating customer details in every order, you create one table for customers and another for orders, linking them with a key. Denormalization, on the other hand, is when you combine or duplicate data to make it faster and retrieve. For instance, you might add customer details directly to the order table so that you don't need to join tables during a query. Normalization helps you space and maintain consistency, while denormalization makes data retrieval quicker depending on what the database needs. Let's move on to the next question, which is what is a clustered index? It's very easy. Just simply answer by saying that a cluster index in SQL determines the physical order of the data rows in a table. Each table can have only one clustered index, which impacts the table's storage structure. Rows in a table are physically stored in the same order as the clustered index key. Now we have next question, which is how do you prevent SQL injection? So talking about this question, SQL injection is a security risk where attackers insert harmful code into SQL queries, potentially accessing or tampering it with your database. To prevent this, you can use parameterized queries or prepare statements to handle user input safely. You can validate inputs to allow only expected values, use stored procedures to separate logic from data, limit database permission, and escape special characters. These steps help you secure that your database is free from SQL injection attacks. The next question on the list is explain the concept of database schema. In SQL, a database schema functions as a conceptual container for housing various database elements such as tables, views, indexes, and procedures. Its primary purpose is facilitate the organization and segregation of these databases elements while specifying their structure and interconnections. The next question is how is data integrity ensured in SQL? Just simply answer by saying that data integrity in SQL is ensured through various means, including constants, example, primary keys, foreign keys, check constants, normalization, transactions, and referential integrity constants as well. These mechanisms prevent invalid or inconsistent data from being stored in the database. Question number 42, which is what is an SQL injection? We have already discussed about how we can protect our data from SQL injections. So now let's discuss what is basically a SQL injection. So SQL injection in cybersecurity attack that involves insertion of malicious SQL code into applications input fields or parameters. This unauthorized action enables attackers to illicitly access a database, extract confidential information, or manipulate the data. The next question is how do we create a stored procedure? You use the create procedure statement to create a stored procedure in SQL. A stored procedure can contain SQL statements, parameters, and variables. So here's a very simple example. You can just simply create by writing this query as create procedure, get employee by ID, at employee ID integer as begin, select star from employees where employee ID is equals to at employee ID. And then you just have to write end. That's it. So next question is what is a deadlock in SQL and how it can be prevented? One more important question often asked in interview. So you have to answer something by saying that a deadlock in SQL happens when two or more transactions are stuck because they are waiting for each other to release resources. It's just like two people trying to go through a narrow door at the same time, each refusing to step back and let the other pass. Transaction A locks table 1 and waits to access table 2. Transaction B locks table 2 and waits to access table 1. This is just a simple example. So we can see that both the transactions are waiting for each other. Neither can proceed, creating a deadlock. So it's very simple. And how we can prevent this deadlock is by locking hierarchies. Always access resources in the same order so that transactions don't block each other. Timeouts. Set a time limit for transaction to wait out for the resources. You can also use deadlock detection and resolution system to detect deadlocks and cancel one transaction and let the other proceed. Now let's move on to a last question on the list, which is difference between in and exist. In basically works on list result set. It doesn't work on subqueries, creating a virtual table with multiple columns. Compares every value in the result list. Performance is comparatively slower for large result set of subquery. Whereas the exist works on virtual tables, it is used with correlated queries, exist comparison when match is found, and the performance is comparatively fast for larger result set of subquery. So guys, that's it for this video on the top 45 SQL interview question asked in SQL interviews. Now, if you have any queries, you can just ask them in the comment section below. Our team of experts will reply you as soon as possible. So keep watching and keep learning with Simplilearn. Thank you for watching.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts. Choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.